Alright, in this video we are going to be talking about how to use quantifiers and quantified statements to reason logically. And to do this as a tool, we're going to develop something called Euler Diagrams. You can think of them like Venn Diagrams, if you like. So let's look at an example of, let's do a universal one first. So let's say the following. All cats have paws. I'll show you how to draw it in two different ways. So the first way, let's think of the following. So imagine that you're God, and you can take all of the cats in the world and put them inside of a fence. So I'm going to do that. I'm going to take all of the cats in the world, I'm going to put them inside this fence. So imagine you're looking down and all the cats in the world are in this fence. So I put all of the cats inside this fence. The next thing I'm going to do is I'm going to put all things that have paws inside of a fence. But if all cats have paws, where do the cats live in relation to this fence? Well, if all cats have paws, then I must be gathering them as well. So if this is the paws fence in blue, if this is everything in there are things that have paws, well, cats have paws as well. All cats have paws, so they must live inside of this fence. So this is things that have paws. And again, there's nothing special about cats or having paws. So in general, if you have all P are Q, then you can draw it in two fences. Put everything that is in P in the middle fence, or in the center fence, and everything that is Q around it. So another way to draw this, if you like, some people like drawing it kind of more as a Venn diagram style thing. So let's say this is our cats, and these are things with paws. Well, if all cats have paws, what does that mean? Well, that means that there are no cats that do not have paws. So nothing lives in this area here. So this area, these are all cats that don't have paws. These are both cats and things with paws, and these are just things with paws that aren't cats. And I guess outside are things that aren't cats and don't have paws. But we can say that that's empty just by putting some hash marks through it, like this, or hatches, I guess. So that's empty. So nothing is in this area. All cats, the only cats that are left, are in this bit of the diagram, and they overlap with things with paws. Let's look at the next one. So let's do some cats are gray. So again, well, if some cats are gray, here's all of our cats inside of that fence. And we'll take everything that's gray in the world and we'll put it in this fence. Things that are gray. And think about what this means. This means that if some cats are gray, we can reword that to say, there is a cat that is gray. So that tells me that there's something that lives in here. So we'll just put a little dot to say that this is a gray cat. So a cat exists that is gray. So that little dot there tells me that this intersection isn't empty. There's something in there. And in general, if we have something like there exists, or some, or there is a P that is also Q, well, that diagram is just going to look, of course, like this. Here are all the things that are P. Here's all the things that are Q. Well, we know that there is a P that is also Q. And there it is. That's a thing that is both P and Q. So you can think, well, why do we even put this dot in? Well, I want to talk a little bit about vacuous statements, and we'll talk a little bit more about this when we talk about conditional statements. But if I say something along the lines of all unicorns are horses, well, I can do the same thing. I can put all unicorns inside. I'll use U for unicorns, and I guess H for horses. I can put all unicorns inside of a fence, and if all unicorns are horses, well, the horses live here, and the unicorns are types of horses, so they live inside of that. But do unicorns exist? They don't. I gathered all unicorns and put them inside a fence, but there are no unicorns in here. So I'll just write that down here. There are no unicorns. Believe it or not, they are not a real animal. So the kind of note I want to make here is that a universal statement does not guarantee, let me scroll a little bit, does not guarantee existence. So that doesn't tell me that there is something in there. It says that all of them, if there is any, all of P have property Q as well. In this case, all unicorns are horses, but it doesn't say that there's anything inside of this fence. But when I'm saying some P or Q, well, that tells me that there's at least one. So that does give me the existence of something. So you just have to be a little bit careful about that. So that dot says that is an actual object that is both P and Q. Let's look at one more example of one, and then I want to talk about, in general, how these regions live. Let's look at this. No cats are dogs. Okay, so if no cats are dogs, if I gather all the cats in the world and all the dogs in the world, well, if no cats are dogs, then none of them overlap. There's none that are going to be in both fences. So the fences are separate. Or if you like, you could draw it kind of more Venn diagram style. Here are cats, here are dogs. And if no cats are dogs, that means that there's nothing in this intersection here. There's nothing that is a cat and a dog. So we'll put some hatches in there to say that that is empty. So you can draw it in either way. And I guess in general, if you have no P or Q, then here's everything that is P. Here's everything that is Q. All right. Let's talk about regions of Euler diagrams. Or you can think of them, there's a slight difference between Euler and Venn diagrams, but we can think of them as the same thing for our purposes. One has to do with logic, one has to do with sets, but it turns out that they're very related, so we won't even care about the distinction too much. So let's just have two circles here. So things with property P, things with property Q. And if you're drawing Venn diagrams, you could draw it like this. Okay, so you could ask, how many regions are in this diagram? And you're probably thinking there are 3 regions. Here's a region here, here's a region here, and a region here. But really there are 4 regions, because there's also the region outside of the diagram. So pause the video now and see if you can determine what objects live in each of the 4 regions. So remember, there's things that have property P, things that have property Q. So pause the video and see if you can determine that. Okay, so the region in the center, well, that's easy. Objects in the center are, they have property P and they have property Q because they overlap. This region here, so that is everything to the left of that intersection here, well, that's things that are in the P fence but not in the Q fence. So things in this region, they have property P and they do not have property Q. Similarly, on the other side here, they don't have property P and they do have property Q. And outside of this diagram, well, they have neither. They don't have property P or Q. So we can write it like this. They don't have property P and they don't have property Q. Or if you like, if you remember from the last video, another way you could write it if you like is they don't have property P or Q, like that. So either one of those is good.